yesterday we have seen the hop adder, how to write the program for the hop adder. That part we have seen, and in it we have found that the hop adder is having two inputs, A and B, and the outputs are sum and cout. Okay, so for the same we got the equation for sum is A XOR B, and for cout we are getting the equation is A and B. Is it clear? And for the same we have written the program for your Verilog. So how we can write the program for Verilog? It's a very simple one. We start with module. Okay, then my module name. So what my module name is? Hop adder. Okay, then there is a port list and port definition. So what is my A and B are? Inputs. What is my sum and cout are? Outputs. Then end with semicolon. Then here we just write the two Boolean equation in Verilog. So this is known as your data flow modeling style. When we write the parallel statement, all these statements are known as concurrent statement. Concurrent statement means both are executed at the same instant. So that statement is sum. We are assigning A XOR B to sum. So assign sum equals to A XOR B. Clear? Sum equals to A XOR B. And assign cout equals to A ampersand B. Clear? And then end with end models. Now this is simple of your Verilog design, and after that we have seen the test bench. So how to write the test bench? So we start with model. Okay, test bench is an environment where we test our design. So test bench is a model without code. ये block के बाहर आपको कुछ भी inputs नहीं दिख रहे. Okay, so that's why this is a test bench. So model name, and here there is no port list. So that's why this is known as test bench model. Okay, now we have to provide the input, okay, to our design, because we want to test this design. So that's why we have taken that register. इसके लिए हमने क्या किया है? A और B को registered data type लिया है. Why registered data type? There are the two reasons. The first one, आपको यहाँ पे A और B की वैल्यू चेंज करना है, और दूसरा रीजन ये है कि what we are going to use here initial block, sequential block. Okay, then second one, here we are taking that output, that is of your wire, because your output is just monitor. आपका output की वैल्यू डिपेंड करेंगे इनपुट के ऊपर. We are not changing the output value by ourselves. So that's why it is a wire data type. Then जिसको आपको टेस्ट करना है उसको कॉल करना पड़ेगा. So what my pre-design name, जो मेरे मॉडल का नाम था वही मुझे यहाँ पे लिखना पड़ेगा. Is it clear? So I have to write the same. So what my model name is? Hop adder. What my model name is? Hop adder. Now there is an instance name. That means you can use multiple times. So that's why here we are having that UUT. आप यहाँ पे कुछ भी नाम दे सकते हैं as per your identifier rules. So UUT का मतलब यहाँ पे क्या हो गया? Unit under test. Okay. Then how to connect their ports? A का port register A के साथ में connect होना चाहिए, B का B के साथ में. So there is a dot A in bracket A. That means this formal port is connected with actual port A. Clear? So dot B B, then dot sum dot cout. Then we start with that different cases, initial, begin. Okay. Then A0, B0, and so on. Then again after 100 nanoseconds we change the value. Again after 100 nanoseconds we change the value, and so on. Clear? Then $finish is a task to finish your simulation. Initial is having that multiple statement, so that's why we start with begin and end, and module, and there is end module. Clear? So same program same design program and same test bench program. यहाँ पे जो आपको वेरीलॉग का प्रोग्राम दिख रहा है, यही प्रोग्राम हमको यूज करना है in EDA Playground. So let's start with this. Okay. So you can open the browser. Okay. And here you can just type EDA Playground. यहाँ पे आपको क्या टाइप करना है? EDA Playground. Clear? So that first link will be open. That is of your edaplayground.com. Is it visible? सबको दिखाई दे रहा है? Yes or no? Is my screen is visible to you? Yes. So have you opened your EDA Playground at your laptop? So parallelly you can do it. Yes. Okay. So first of all, here you have to log in yourself. So either you can create a register for a full account, okay, or you can directly log in with Google. So log in with Google. So I just try to log in here. Okay. So I just log in here. Are you getting here? आपको क्या करना है? EDA Playground का वेब पेज ओपन करना है और वो वेब पेज पे आपको लॉग इन करना है. Is that clear? Okay. Now let me know, have you log in on EDA Playground or not? कितने लोगों ने लॉग इन किया है यहाँ पे? Yes. प्रगति, प्रणव, done. Very correct. Bhakti, can you mute yourself? Okay, fine. So once you have logged in, okay, then here you can write the code. So what the code for my half adder, we are going to execute here half adder. So what the code of half adder is? Half adder का code क्या है? So module, I can write here. So what the code of half adder is? Okay. So I can just write it module. Okay. If it is visible for you, half underscore adder in bracket, you can have input A comma B, clear? Then comma, what is that? Output, it should be lowercase. So output, what is that? Sum comma C out. I'm having the two outputs, clear? Then I just write here the statements for data flow modeling style, that is assign, what is that? Sum equals to, क्या मिल रहा है मुझे? Sum equals to A XOR B, clear? Semicolon. What the next one is? Assign cout equals to so you may complete your program. So this is my design program. Okay, this is my design program. Okay, so I should write here at design side, design.sv. Clear? Here I have to write Testbench. At right window, I have to write my design programs, and at left window, I have to write my Testbench code. So what my Testbench code is, if you know that, the Testbench code that yesterday we have seen. So we are going for this Testbench code. So let me check what we are getting a Testbench code for this. Okay, so we should start with module, then what my module name? It is TB. It should be different than your design. आपके डिजाइन का नाम क्या था? Half underscore adder. Okay, then it should not having port list. So Testbench is a module without port. Clear? So अभी input आपको देना है. So for input we define the data type is register. So register A, B. Okay. Output, that is a wire. What is that? Wire. Yes, anyone? What should my output is? Sum and cout. My output wire should be sum and cout. Very correct. So sum, comma, cout. Where?
Recording in progress.
Okay. So my wire is sum, comma, cout. What to write next? इसके बाद में क्या है? You have to call your design. So आपका जो डिजाइन था उसको आपको यहाँ पे बुलाना पड़ेगा. Okay. That means here you have to instantiate. So half underscore adder, and what is that? It is UUT, unit under test. And here you have to connect. do that port mapping. So how we can do the port mapping? Dot A in bracket A, okay, that means A किसके साथ में कनेक्ट हो गया? टेस्ट बेंच के A के साथ में. So dot B in bracket B, okay, then what is that? What is it? Dot sum in bracket sum, okay, comma, dot cout in bracket cout, then bracket complete, semicolon. Any doubt? Okay. Then initial is a procedure block where you can write your sequential statement. So begin, if you're having a multiple statements, it should be within begin and end. Okay. Now, whatever the statement we have written inside initial, जो कुछ भी हम statement लिखने वाले हैं initial के अंदर, ये सभी statements sequentially execute होने वाले हैं. All the statements will execute sequentially. So what we are going to execute? A equals to 0. Okay. Then B equals to 0. We wait for, let's assume 100 nanoseconds. Clear? Then what my second case will be? A equals to 0 and B equals to 1. Clear? What my third? So again I am waiting for 100 nanoseconds. What my third case becomes? A equals to 0. Okay. Sorry, A equals to 1. And what is my B equals to? 0. Again I am waiting for 100 nanosecond. And what is my last case will be? मेरी last case करेंगे A equals to 1 and B equals to 1. Then we wait for 100 nanosecond. Then here we can write dollar finish. So dollar finish एक task है जो क्या करेंगे आपके simulation को end करेंगे. Clear? So this is simple one. But here we want to go for waveform. So ये जो कुछ भी वैल्यू आने वाली है इसको हमको डंप करना है. ओके किस में डंप करना है? VCD फाइल, वैल्यू चेंज डंप. ओके सो फॉर दैट अभी आपने अगर चेक किया होगा तो आपने Xilinx विवाडो में डंप का कुछ यूज नहीं किया था क्योंकि वहां पे डायरेक्टली आपका सिमुलेटर आपको वेवफॉर्म प्रोवाइड कर रहा था. लेकिन यहाँ पे आपको वैल्यूज देना पड़ेगा so that your waveform will generate. So these are the two very important tasks that is of your dollar dump file. आपको एक dump file create करना है and that name is okay in double inverted. It is dump dot, you can give that any name, no problem. Dump dot extension is VCD, value change dump. Clear? Semicolon, and also here you have to take one variable and that variable name is dump vars. Okay, in bracket 1 semicolon. So for EDA Playground to get a output waveform, so these two tasks here we have to add. What is that? Dollar dump file and dollar dump vars. Are you getting it? Is it clear? Is that clear? Here I am just opening the Xilinx vivaडो so that you are getting a difference. Let me know, is that clear? समझ में आया क्या? टेस्ट बेंच कोड में आपको कहाँ पे चेंज करना है? ओनली हियर यू हैव टू ऐड दिस टू स्टेटमेंट. ओके, थैंक यू फाल्गुनी फॉर योर काइंड रिस्पॉन्स. प्रज्वल, यस. Okay. Once you have written this, okay, then you can save as. So यहाँ पे आपको शेयर के नीचे, प्रोग्राम के नीचे एक शेयर और लॉक करके है. So शेयर के नीचे add a title to help your find your playground. So आपका प्लेग्राउंड पे जो प्रोफाइल बनने वाला है वहां पे फाइल कौन से नाम से सेव होने वाली है? What the questions? Is this only for EDA Playground? No, it is applicable for everyone. Dump file and dump vars is applicable for everything. But in Xilinx simulator, it will generate the waveform itself because there is a test bench environment also there. But maybe you may find if you are going for the cadence Xilium, then that times there is no simulator for your output waveforms. So then that times with respect to your dump value, the waveform will generate. Okay. So this is a standard Verilog syntax, okay, where we use dump file to dump your value for a waveforms. Okay, whatever the values you are getting it, that will be dumped for your output waveforms. Clear? So it's not only for EDA, it is overall accepted. Clear? But here in EDA playgrounds, we are not having that directly waveform simulators. So that's why first of all here we have to dump this value in a file dump.vcd and that will be called for your waveform. Is it clear? Mandar? Okay. So to save this file, here I'm just writing that half underscore adder. Okay. And public. Okay, there are three options. Private, only you can view. Publish will appear in search results, and public, anyone with the link can view. So we will do that publicly, no problem. Then save. Please select a valid tools. Okay, before going for save the options, here you have to do that certain setting. Okay, यहाँ तक हो गया क्या सभी का? अगर आप पैरेलली सिमुलेट अगर कर रहे होंगे या फिर प्रोग्राम कर रहे होंगे हैंड्स ऑन EDA प्लेग्राउंड, so let me know, is that over up to this? Yes. Okay, so what the setting here you have to do, that's a very important. So just see it here carefully. So first of all, go in the languages. यहाँ पे आपको लेफ्ट हैंड साइड में वर्टिकल बार में आपको दिख रहा होगा EDA प्लेग्राउंड के जस्ट नीचे languages and libraries, then tools and simulator. Okay, so first of all we have to select the language. So click on language. So by default Testbench and design, so it is of your system Verilog and Verilog. Okay, so we just click on that system Verilog and Verilog. Then EVM, OVM none, other libraries also none. Okay, समझ में आ गया? Just select here system Verilog and Verilog, that is a by default. Second, आपको करना है tools में setting, tools and simulator आपको दिख रहा है? Tools and simulator, yes or no? I find that tools and simulator. Okay, so tools and simulator, तो सबसे पहले है select. तो select में जाके we are going for LDEC, Rivera Pro. Okay, we are using this simulator tool LDEC. So click on LDEC Rivera Pro 2025.04. Clear? Then time scale 1 nanosecond by 1 nanoseconds. Okay. Then here run time 100 millisecond, no problem. एंड जस्ट क्लिक ऑन ओपन ईपी वेव। आपको कहां पे क्लिक करना है? ओपन ईपी वेव, सो योर वेव फॉर्म विल ओपन आफ्टर रन। आर यू गेटिंग इट? सिर्फ दो सेटिंग है, एक है सबसे पहले लैंग्वेज, ओके, एंड सेकंड इज ऑफ। सेकंड इज ऑफ, व्हाट इज इट? सेकंड कौन सी है? tools and simulator. So we have to just select that tools and simulator is LDEC, Revera. Is that clear? Let me know. Is it clear? Yes. Okay. So select on open EP and then try to save it first. So right now it's saved. वहां पे इसका स्टार चला गया. Clear? It's saved. Your file is saved. Okay. Then run. इसके बाद में आपको क्या करना है? Directly run. So we run it. If there is any error, that will come in that log. Okay. So failure, what the error here we are getting that? The time scale. Okay. So here, whenever we are going for any design or any test bench simulations, so first here you have to add the time directive and that is done by, यहाँ पे क्या मिस्टेक है, यहाँ पे क्या वार्निंग आ रही है और एरर यहाँ पे आप चेक कर सकते हैं. ओके, we leave work and we log time scale 1 nanosecond by 1 nanosecond design.sv testbench sv and vsimc do. We have to do it. Okay. Error, syntax error, unexpected token, non-printable testbench 27. End के बाद में क्या रहेगा? End module. End module छोड़िए अपना. Okay. Let's try for once again. Run. Is it done? Are you getting here the waveform? And check your output. Even if there is a radix also. So we are having the radix is binary. Now check it. What is that? 0 and 0, sorry, 0 plus 0. What my Cout is? 0. Sum is 0. Clear? Then second, just make your mouse or cursor on 100 to 200 nanosecond. So check it. 0 plus 1. 0 plus 1. Okay. What is Cout is? 0. Sum is 1. Are you getting it? Then what is that? 1 plus 0. Sum is 1. Cout is 0. And the last one, what happened? What happened here? 1 plus 1. A plus B. Sum is 0 and Cout is 1. So congratulations, you simulate the test bench correctly and you are getting a proper output waveform. Any doubt, any difficulty? How many of you not getting the things? Anil, Bhakti, आप लोगों का आया है क्या? Sir, in my code there is an error. Okay. So identify in logbook. कौन सा error है? Check करो. You can also cross check. the code with you. You can cross check here the code. So have you mentioned this dump file and dump var after begin, Bhakti? Yes. Okay. Then A, B values. Have you done with end and end module? Can you share your screenshot on my WhatsApp if you are not getting the things, or you may share here also. Sir, timescale code में नहीं लिखा. Still, is it okay? Yes. Yes, it's okay. Because while in run option or while in compile options, so it has taken the time scale. It has taken a time scale here. The option is given. So that's why there is no problem. Okay, इसका मतलब क्या होता है? Time scale का मतलब क्या होता है? This time scale, that means if you write here the time scale, okay, let us assume this is a tick time scale. Actually, this is a directory. Tick time scale 1 nanosecond by 1 nanosecond. So ये जो first वाला 1 nanosecond है, that shows unit. इसका मतलब आपने यहाँ पे क्या किया है? 100 किया है ना? So it means it is having a delay of 100 nanosecond. Are you getting this? This is the delay of your 100 nanosecond. And second 1 nanosecond, that is of your denominator side, or that is of your by 1 nanosecond. This is known as your precision time. इसको हम क्या बोलते हैं? Precision time. Precision time means after every nanoseconds your data is saved. Okay, so that is another precision, and this is time unit. The first nanosecond is of your time unit, second nanosecond is of your precision. Is that clear? Yes. Any doubt? Is that done? All of you? You can also try on your mobile also. No problems. On mobile also you are getting a result. Shall we try for another model? Shall we try for your full adder or any gate? Okay. So what here you have to do? Okay. So we just save it, and if you want to make it new, you can do that new, as well as you can check your playground. आपका ये जो फाइल है हाफ एडर का, ये सेव हुआ क्या नहीं हुआ, ये आप चेक कर सकते हैं. कहाँ पे चेक करेंगे? योर प्लेग्राउंड. सो क्लिक ऑन योर प्लेग्राउंड and you may find today 2nd April 26 there is a half adder program is saved, and it is a public. If you click on this half adder, it will be open. The program will be open. Clear? Is that clear? So just click on playground at a right corner. Okay. Then click on your playground. Click on your playground. Here you find whatever the design you have done. Okay. That is a half adder. So it shows. If you click on it, the program will open.